For years, astronomers have watched one of the sky's brightest and most unpredictable giants, Betelgeuse, the red supergiant trembling on the edge of oblivion. They told us its end was coming. They just didn't know when. Now, the internet is erupting with claims that the James Webb Space Telescope has captured the unthinkable, the first moments of Betelgeuse's collapse. But this isn't the tale of a star simply blowing apart. It's a far stranger drama, one involving a hidden companion, a turbulent past, and a cosmic twist that reshapes our understanding of dying suns. The viral headlines don't tell the real story. To uncover that, we have to go deeper. Because the truth isn't one explosive moment, it's the slow, violent unraveling of a star tearing itself from the inside out. The most dramatic chapter of this story began in late 2019. Astronomers worldwide noticed something deeply bizarre. Betelgeuse, the unmistakable fiery orange shoulder of the hunter Orion, was fading. And not by a small amount. It was dimming dramatically. In a phenomenon that quickly became known as the Great Dimming, the star lost more than 2/3 of its usual brilliant light. The change was so significant that even casual stargazers could see it with the naked eye. Orion looked wounded, its famous shoulder suddenly faint. This event triggered a wave of global speculation. Was this it? Was this the final, sputtering breath before the inevitable supernova? Was humanity about to witness an event not seen in our galaxy for over 400 years? The answer, as we now understand it, is no. But the real explanation reveals the raw, untamable power of the universe itself. What we are witnessing aren't its final moments, but rather an intimate, unprecedented look at the chaotic, messy, and glorious process of a star's final life stages. The headlines are wrong, but the science they misinterpret is a genuine revelation. To grasp what's happening, you first need to understand that Betelgeuse is no ordinary star. Calling it a red supergiant is a profound understatement. It is a monster of almost incomprehensible scale. If you were to place Betelgeuse in the center of our solar system, where our sun resides, its fiery surface wouldn't just swallow Mercury and Venus. It would engulf our own planet Earth, vaporize Mars, and its outer tendrils would stretch deep into the asteroid belt, perhaps even brushing the orbit of Jupiter. It is so unimaginably vast that its volume could comfortably hold billions of our suns. And yet, for all its size, it's a cosmic toddler, only about 10 million years old. Our sun, by comparison, is a middle-aged 4.6 billion years old. This is the paradox of massive stars. They live fast, burn bright, and die spectacularly young. They tear through their primary fuel, hydrogen, with reckless abandon, shining with the light of 100,000 suns. Right now, Betelgeuse is in its twilight years. Having exhausted its hydrogen, it's desperately fusing heavier and heavier elements in its core, helium into carbon, carbon into neon, and so on down the periodic table. Each stage provides a temporary reprieve, a new source of energy to push back against the crushing force of its own gravity. But this process cannot last. Eventually, its core will be left with iron, and for a massive star, iron is a death sentence. Fusing iron doesn't release energy, it consumes it. The outward pressure that has held the star up for millions of years will vanish. In less than a second, the core will collapse under its own colossal weight, triggering a rebound shockwave of unimaginable power. Betelgeuse will tear itself apart in a Type II supernova. This isn't a possibility, it's a guarantee written in the fundamental laws of physics. The only question is, when? This brings us back to the Great Dimming of 2019. As the world watched and wondered, the world's most powerful telescopes turned their gaze toward Orion, and what they pieced together was stunning. Betelgeuse hadn't begun to collapse. It had, in a fit of stellar rage, violently ejected a colossal piece of itself into space, a surface mass ejection. Think of a solar flare from our own sun, but scaled up to a truly biblical level. This titanic blob of superheated plasma, containing many times the mass of our moon, was hurled out into the void. As it traveled away from the star, it cooled and condensed into an opaque, impenetrable cloud of dusty soot. It was this self-made celestial shroud floating between us and the star that blocked its light and caused the great dimming. It wasn't a death rattle. It was a staggering demonstration of just how volatile and unpredictable these dying giants are. The star had literally blown its top. But there's another layer to this mystery, something else pulling the strings. For decades, astronomers had noted a second, longer, and more subtle rhythm in Betelgeuse's light, a gentle pulse lasting about 6 years. A lone star shouldn't behave that way. Something else had to be there, a hidden influence in the system. After painstakingly analyzing data from the Hubble Space Telescope and powerful ground-based observatories, astronomers found the culprit. A hidden companion star, now named Sawarha. It orbits so perilously close that it actually plows through the supergiant's wispy, extended outer atmosphere. This interaction creates a colossal wake, like a speedboat cutting through the calm water of a lake, disrupting the very surface of Betelgeuse. The discovery was a monumental breakthrough. This Beetle Buddy isn't just a bystander, it's a crucial character in Betelgeuse's ongoing drama, likely contributing to the instability that leads to its massive ejections. And now, finally, we come to the James Webb Space Telescope. When headlines sensationally claim that Webb captured Betelgeuse exploding, they are being fundamentally misleading. Betelgeuse is, for Webb's purposes, overwhelmingly brilliant. Pointing its incredibly sensitive infrared instruments directly at it for a long period would be like trying to take a photograph of a delicate firefly by staring directly into the blinding exhaust of a jet engine. The instruments would be completely saturated, the data useless. But Webb's role in this story is far more profound and clever. Its power lies in its unparalleled infrared vision, which allows it to peer through the very cosmic dust that shrouds dying stars and obscures them from view. Just recently, JWST observed another red supergiant in the period just before it exploded, a star so cloaked in dust that it was practically invisible to other observatories. Webb saw it clearly, charting the final stages of its life. This is the key to how Webb is unlocking the mystery of Betelgeuse. It isn't watching the star directly, but it is studying its cosmic cousins to learn the family secrets. It's building the definitive playbook for stellar death, showing scientists the telltale signs, the hidden processes, and the final chapter. We are not witnessing an explosion. We are witnessing the process of a star dying, which is scientifically far more fascinating.